Alright, as we move on to assignment number 4, we're going to learn how to add and subtract radicals. We're going to be multiplying radical binomials and then rationalizing the denominator with radical binomials in them. So a lot to learn here. Pay attention as we go through this video, and you might want to pause the video as we do certain examples as we have done in the past, just to try them before we go over them together. So let's go ahead and get started. So let's take a look at number 1 and number 2 first. We want to simplify these radicals. Number 1, we're subtracting. Number 2, we're adding. So here we have different indexes for the two radicals, and here we have different bases within the radicals. Both of those mean that we cannot add or subtract them. We have to have completely like terms in order to add them together. We could do something like this. If we had 5 times the square root of 2 plus 3 times the square root of 2, we could add those together. That would be 8 radical 2's. But the reason we can do that is because the radicals are identical. But we cannot do number 1, we cannot do number 2. And so that's just a situation where you have to stop. You can't do it unless the radicals are identical to each other. So let's move on and look at ones that we can do. Take a look at number 3. 5 radical 6 plus 3 radical 6 is simply 8 radical 6. Looks like number 4 we can't do at first, but that's because it's not simplified. We can simplify the square root of 50. That's the same thing as 25 times 2, or the square root of 25 times the square root of 2. So this is 5 radical 2 plus, we have the square root of 32 here, which is 16 times 2. The square root of 16 is 4, and 4 times 3 is 12 radical 2. And then minus, we have the square root of 18, but that's the square root of 9 times the square root of 2, and the square root of 9 is 3. And so 3 times 5 is 15 radical 2. So now we can, because those radical are all radical 2's, and so 5 plus 12 is 17 radical 2's, minus 15 radical 2's is 2 radical 2's. And so we can put those together like that. That's adding and subtracting radicals. Simplifying them first, and then if they're the same, we can add and subtract like terms. So let's move on and take a look at multiplying binomials together. And before we do 5 or 6, I'm going to just go back and do a problem like this first. Let's say that we had 5 plus 2 radical 3. That is a radical binomial. And we're multiplying that by another radical binomial, which is 4 minus the square root of 3. So if I were to multiply these together, I'd have to FOIL here. In other words, I'm going to take 5 times 4 is 20. You can just watch this. You don't have to take notes on this. But then I'm going to take 5 times negative radical 3, which is negative 5 radical 3. Then I'm going to multiply my inside terms together. 2 times the 4, well, that's 8 radical 3. And then 2 times negative 1 is negative 2. Radical 3 times radical 3 is radical 9. Well, the square root of 9 is 3. So this is like minus 6 here. And 20 minus 6 is 14. And then I have negative 5 and a positive 8, which is a positive 3 radical 3. And so you can see here that in order to multiply radicals together, we're going to have to FOIL them. And so now let's move on and take a look at 5 and 6. So radical 2 minus radical 3 squared means we're going to take radical 2 minus radical 3 and multiply it by itself, which is radical 2 minus radical 3. So if I take radical 2 times radical 2, that just gives me 2. Radical 2 times negative radical 3 is negative radical 6. Negative radical 3 times radical 2 is another negative radical 6. And then negative radical 3 times a negative radical 3 is a positive radical 9, which is positive 3. So when I combine my like terms, then 2 plus 3 is 5. And then I have minus 2 radical 6's. And that would be my answer for number 5. If we look on to number 6, Now, these are called conjugates of each other because everything's the same except the sign in the middle, but I want you to see what happens when we multiply two conjugates together. 5 times 5 gives me 25. 5 times negative radical 2 is negative 5 radical 2. Then positive radical 2 times 5 is positive 5 radical 2. And positive radical 2 times negative radical 2 is negative radical 4, which is negative 2. So we have 25 minus 2, which is 23. And then my positive and negative 5 radical 2's cancel each other out, and my final answer is just 23. So you can see when we multiply conjugates together, all the radicals will disappear, and I'll just get a real number, 23. That's going to help us in a situation like this. We want to rationalize the denominator here. So I can't just cross off the radical 5's. For the same reason I couldn't cross off the radical 5's if I had something like this. If I had 4 plus 2 over 1 plus 2, the answer is not 4. It's not like I can cross off those out. It's not 4. This is the same thing as 6 over 3. The answer is 2 here. And so I can't just cross off the 5's. But I have to rationalize the denominator. I can't have a radical in the denominator. And so I have a binomial down here, so what I want to do is multiply by its conjugate. And so instead of 1 minus radical 5, I'm going to multiply by 1 plus radical 5. And if I multiply the denominator by 1 plus radical 5, I'm going to have to multiply the numerator by 1 plus radical 5. So let's do the denominators first. If I multiply 1 times 1, I get 1. And then I'm going to get plus radical 5 if I multiply 1 times radical 5. Then negative radical 5 times 1 is negative radical 5. And then negative 5 times positive, negative radical 5 times positive radical 5 is simply just a negative 5. I could say negative radical 25, which is negative 5. Well, these will cancel each other out. 1 minus 5 is negative 4. So I'm going to have a negative 4 in the denominator. Now if I multiply the numerators together, I'm going to take 3 times 1 is 3. 3 times radical 5 is 3 radical 5. And then radical 5 times 1 is just radical 5. And then radical 5 times radical 5 is positive radical 25, which is positive 5. And so when I simplify this, 3 times 5 is 8, plus 3 radical 5 plus another radical 5 is 4 radical 5. So it's going to be 8 plus 4 radical 5. And now I can simplify the 8, the 4, and the negative 4. That's the same thing as 2 plus radical 5 over negative 1, which is the same thing as negative 2 minus radical 5. And so my final answer here, if I rationalize the denominator, is negative 2 minus the square root of 5. These are the type of things we're going to be doing on our homework, adding and subtracting radicals, multiplying radical binomials together, and then rationalizing the denominator with a radical binomial in it. That's what we're going to be doing on our homework assignment for tonight or tomorrow, and we will see you tomorrow in class.